first two words harmonic we're going to start off with. Cut off the border. Here on the left, right, out every box. Cycle. So we're going to go through and we're going to provide you with the vocabulary to describe a cycle how is harmonic motion is different from one repetition of the motion. First two words we're going to start off with repetition. Here on the left, right, cycle. Okay? A cycle. A cycle is one complete repetition of the motion. Okay? One complete repetition. So the pictures, you can leave them glued together. Just you can leave them together. Just a little bit of glue. Go ahead and glue those in. Whatever color you use for equilibrium position, set it to the side. Use a different color. So, cycle. One complete repetition of the motion. So a cycle. It starts here, it goes all the way to there, and then it comes all the way back, and it's back to where it started. Starts here, goes all the way over, and then comes all the way back to where it started from. That's one cycle. So a little note if you want to over here, the way I like to remember cycle, it's here to there and back. So when we're talking about the spring pendulum, one complete cycle, all right, so this is when it's stretched out. Here's the equilibrium position. Your color for equilibrium position, that you can use right here. Equilibrium position. Right here's our equilibrium position. I pull it down and let it go, and it's going to go all the way up. So from the top, all the way down, and then all the way back up to the top. That's one cycle. Because once it's there, it does it again. So when you get back to where you started from, that's one cycle. So if you think about a wheel, a wheel that goes around when you get back to where you started from, that's gone through one cycle. You go down and back, that's one cycle. Over and back, one cycle. The next keyword, amplitude. Amplitude is the maximum distance or angle of the motion from equilibrium. Amplitude. If you see in this diagram here the pendulum, right there it says amplitude. It's trying to describe that angle. Okay, so think about geometry, all right, the angle, that's what it's describing. And there's the fancy little symbol for angle, all right? So the angle of the motion, the maximum, all right? So the maximum angle. So this is the equilibrium position right here, which you can highlight with your equilibrium position color. That equilibrium position, it swings as far out as as far as it swings out. That angle from the equilibrium position, that is the amplitude. If you're looking at a spring pendulum, the up and down, this is the equilibrium position. It gets as high as right there, and it gets as low as right there. Now, this distance from equilibrium position up or equilibrium position and down, those are the same distance. You could measure those, and each of those would be the same length. Likewise, over here, if you were to measure the angle on this side of equilibrium or on that side of the equilibrium, it would be the same angle. Cycle and amplitude are two ways to describe the motion and the dimensions of a pendulum. Now, little squiggly line there in your notes. Now we're going to discuss two variables. Period, which is an uppercase T, is the amount of time it takes to complete one cycle. So one cycle, the amount of time it takes to go from here to there and back. From here to there and back, one cycle. All right? When I grew up as a kid, the washing machine, we would say, oh, put it through a wash cycle. And I have to laugh now because now I understand why we call it a cycle. Because the dial, you would turn it to a certain position, hit start, and it would slowly rotate around while it did the whole entire wash and end up back where it started. Okay? So it was one cycle of the little knob. So our units of measure for period is seconds. Because we're just counting the time it takes to do something. Okay? So when we've always counted time before, it was always a lowercase t, right? Time, always a lowercase t. This is an uppercase T to emphasize it's the time for one cycle. So we have to make it just a little bit different. So we're not just talking about time in general, we're talking about time for one cycle specifically. That makes an uppercase T. Similar concept. Frequency. Symbol for frequency is a lowercase f with the little curly Q tail on it. A lot of people don't put the curly Q tail, but it's technically supposed to be there. Okay? Frequency is the number of cycles that occur per second. So frequency is the number of cycles that occur per second. Units of measure are new. They're called hertz, named after a famous nerd. All right? Capital H. Yes, that is the name of a rental car company. The symbol for that is capital H, lowercase z. Hertz, the number of cycles that occur in 1 second. So if you're talking about something that's swinging back and forth really fast, how many times does it get back and forth doing cycles? How many cycles happen in just 1 second? All right? Something you can relate to, for those of you who know cars, RPM, when your engine goes, that moment, it has a high RPM. Okay? It means revolutions per minute. If you know motors, you understand what it's saying by revolutions, and it's measuring how many happen in a minute. Okay? Revolutions per minute, same thing as frequency, just a slightly different perspective. We're talking about cycles per second rather than revolutions per minute. It's like miles per hour and meters per second. It's the same idea, just a different units of measure. Now, there's a special way it's helpful to look at these. Period, uppercase T, is equal to seconds divided by cycle. How many seconds happen in 1 cycle? All right, so how many seconds it takes to do 1 cycle. Whereas frequency is the number of cycles that happen in 1 second. So cycles in 1 second. If you look at these very closely, they're just the inverse of the other. Seconds in cycle or cycles in seconds. So seconds per cycle, cycles per second. So period and frequency are kind of describing the same thing. It's just your perspective. All right? Kind of like two different sides of the same coin. It's still a quarter, it's just heads up or it's tails up. It's still the same idea. Okay? The key is to pay attention to your units. And if you look at the two formulas, they are very, very similar. Now that you have the formulas glued in, let's label them. T is period, measured in seconds. F is frequency, measured in hertz. So if I know the frequency, I can figure out the period. Likewise, if I look at the other formula, if I'm solving for frequency in hertz, all I need to know is how many seconds it takes to do 1 cycle. So all I need to know is the period in seconds to calculate for the frequency in hertz. Likewise, if I know the frequency in hertz, I can calculate for the period in seconds. And if you notice, they're kind of like the same formula. You just take the other one and you divide it by 1. So 1 divided by frequency gives you period. 1 divided by period gives you frequency. Okay? Fairly simple math. Frequency is what we use most, but it's helpful to know period and understand the concept.